Hi, here's Wenze. I choose the cirrhosis disease classification project. First is first is libraries. I installed and improved the necessary Python packages, remaining them for convenience. I will just select some packages to explain here, such like Seaborn and Matplotlib to data visualization. NumPy are for mathematical analysis, and for the data dictionary, it explains the meaning of each columns in the dataset. After reading the dataset, I assign them into data frame DF and inspect in its structure. The next part is exploratory data analysis, and the dataset contains 418 rows and 20 columns with 10 of the float tab columns and 3 of integer tabs and 7 objective tab and and here is the columns of the data frame and drop the unimportant column ID and divided the remaining columns into quantitative features and categorical features, and the target is the stage. I checked the unit value of the status column and used SNA count the missing value in the dataset, and also check the duplicate rows using describe and generate the basic summary of the dataset. And the next very important part is processing. For missing values, after using SNA function above, I identify the columns of missing value in both quantitative and categorical features. Instead of replacing missing values with the median or mean, I replace them with zeros. The next is encoding target. The target value is stage, which represents the histological stage of the disease 1, 2, 3, 1, 2, 3, 4. However, we want to encode it into binary values. 1 is positive for cirrhosis and 0 is negative for cirrhosis, similar to logistic regression outcomes. To achieve this, I used the double equal signs to compare the values in the stage column. If the values was 4, it was encoded as 1. Otherwise, it was encoded as 0. After encoding, I recheck this dataset and then converting quant features to numerical format. Although the quant features appear numerical, some might have been stored as strings due to formatting issues. Using this code to ensure that any non-convertible values were replaced with NA instead of causing errors, the transformer quant features were then assigned to X. And next is skewness analysis. And using this code to calculate the skewness of each feature, features with skewness greater than 1 were long transformers using log 1p, which means log 1px equal to log 1 plus x. Highly skinned data is common in medical datasets and can negatively impact the model performance. And the next part is outliers. Outlier detection treatment. Here we use two methods, two-key rule and winsorization. The two-key rule is interquantile range method to detect outliers. And using this numeric, I literally strip the data and identify the index of value outside this upper and lower limit. So for outlier treatments, I applied winsorization to the quant features. Instead of removing outliers, winsorization adjusts them to fall within a specific range. The limit 0.05 means that the smallest 5% of value are replaced with a 5 percentile value, and the largest of the 5% are replaced with the 95 percentile value. This method is particularly suitable for medical data, as outliers may represent critical disease of the indicator. After winsorization, update the dataset with the transformer quant features. Any remaining NA values were replaced with 0. Next is dummy encoding. Using this code to perform one-hot encoding on categorical features. This covered each category into a separate binary column, making all features numerical. And this one to avoid multicollinearity by dropping the first category, which can be inferred from the remaining columns. We finally select the 7 key variables as predictor X. The target variable Y is whether the patient have cirrhosis disease. I concentrate X and Y using this function and to create the final data set in column level. At this stage, the mean value of the Y is 0.3445. Correlation analysis, I calculate the correlation matrix for all numerical variables using Pearson correlation method, visualize the correlation matrix using the heat map with the following customization. The figure size is 18 and 10, and seaborne theme is dark grilled style. Color pattern is from dark to light for positive and negative correlation. And annotation displaying correlation values on the heat map, and title is correlation heat map. We can see this one is bilirubin and the stage have the positive correlation, and the porphyrombin and the stage also have the high positive correlation, which is 0.35 and 0.28. The most important part of this project is classifier. For the experimental setup, first I prepare X and Y for processing, ensuring the data is ready for training and evaluating classification and models. Using this one to divide the data set into 80% training set and 20% testing set. And here is to ensure consistent display the reproducibility. This approach helps prevent overfitting. And here, this code is to standardize the features, transforming them to have a mean of 0 and a standard deviation of 1. And this code is handling class imbalance with mode to generate synthetic sample for the minority class. In medical datasets, the target variable is often imbalanced. For example, 90% of cases may be early stage cirrhosis disease, while only 10% are advanced stage. This ensures that model does not over-predict the majority class. And the next is decision tree classifier. I built a pipeline to integrate the data pre-processing. This prevents data leakage by ensuring all pre-processing steps are applied strictly to training set before being used on the test set. The pipeline consists of factors which I have already explained in the about. And after training the pipeline, I use the train decision tree model to predict the test set. Across validation is 0.67 and the accuracy is 0.62. 64, and which indicates that the moderate performance across different data split. While the model shows have some ability to identify positive cases, so relatively have high Fn and Fp, which is 13 and 18, indicating that a need of further optimization. And the final part is PY carrier low code classifier. This model includes comparison and optimization. First is also setting up, which is the same I said before, and I also read them up here. And the PY caret automatically compares multiple models based on the default metrics. It ranks the models and selects the best performing one. The best model identified was extra trees classifier. I turned in the hyperparameters to improve the performance, but untuned model with final choice. You can see here and here. And finally, I trained the model on the entire data set using finalized model. The final extra trace classify achieves accuracy is 75% and pressures is 66.29% and recall is 16%. Build accuracy is good. The relatively low recall indicates the model struggles to capture all positive cases, potentially leading to missed diagnosis.